And to give us more details in terms of what, of course, has unfolded today and also what India, of course, is aiming for, we're being joined by Dr. Ajay Lele, who's a senior fellow at the Manohar Parikar Institute for Defence Studies and Analysis. He's joining us live on this broadcast. Now, Dr. Lele, this is a significant moment in India's quest to become a nation that can actually soft land on the surface of the moon. Now, for people who are watching this who do not understand what a soft landing means, give us a sense of what actually entails in a soft landing on the moon and why is it so crucial?
As far as soft landing on the moon is concerned, India tried its luck in the year 2019 with a mission called Chandrayaan-2. That mission had two objectives. One was to put a orbiter into the close vicinity of the moon, that is in the lunar orbit, and other aspect was to do a soft landing on the moon. Soft landing means you send a robotic equipment on the moon surface, make it land on the moon surface, and take another equipment out of the belly of that equipment. So the mother equipment is known as a lander.
Right.
So that equipment lands on the moon surface, and the rover equipment gets out of the mother equipment and starts operating on the moon surface. As a pre-programmed equipment, it starts moving on the moon surface and starts picking up observations. At places, it can go slightly 10 centimeters deep into the moon surface and also have a look at the soil on the moon surface. There are operations which are pre-planned. So there is a mineralogical mapping which happens. There's a chemical analysis which happens. And that rover sends the messages back to the lander.
Right.
And that lander sends the messages back to the orbiter, and the messages are picked up on the Earth's ground station. So India failed to do that in the year 2019. Now India is reattempting that, and in that direction, the first step successfully has taken place today when India has launched the Chandrayaan-3 missions. It will take another 40 to 42 days to get into the orbit of the moon and subsequently get deorbited and land onto the surface of the moon as a single unit, a lander. And subsequently, the rover will get out of the belly of a lander and start undertaking observations. So it's not only lander or a rover, both the systems will start undertaking different types of observations. They have got different sensors on board, what we call as payloads.
All right, indeed. Now, Mr. Lele, what is also interesting is that India is trying to land on the south pole of the moon. Tell us, our viewers, why it is important to land on the south pole of the moon. Why is it that this particular destination was chosen and not any other destination?
As you were mentioning earlier, there are only 3 countries who have done the soft landing of the moon. So most of these soft landings on the moon have happened at an equatorial region. What happens on the surface of the moon is that you require solar energy basically to keep your systems operational. So equator is a place where you will have abundance amount of a solar energy continuously available. But as you start moving closer to the South Pole, you see South Pole could be considered at 90 degrees at the latitude of the equator, south of the equator. India is planning to land around 70 degrees of latitude towards the south. Right. Now the issue over here is that you require a sunrise also, you require sun rays also. At the same time, you require certain areas where the sun is not going to reach. The reason behind this is that in the year 2008-2009, when India did its first mission to the moon, India has identified the presence of a water on the moon. Now, this presence of a water is in form of hydrogen molecules. Now, India wants to dig further deep over here. Now, since the temperatures on the moon are exorbitantly high in the morning period, hence there is no possibility of the water to stand there on the equatorial region or other region. The presence of water could be only there where there is a total shadow region. That means no sun rays are reaching over there. So these regions are close to the South Pole. There's a possibility that there could be a water available, not as a pure water what you and me drink, but in form of a frozen ice or something. So that understanding is more importantly required since India has already done a testing and found out there is a water available. So this one can say as a step 2 in that direction. And that's the reason India has decided to land onto the south pole of the moon, closer to the south pole of the moon. It takes good amount of a technical expertise to do these types of activities
Absolutely.
also, because you require more amount of a fuel to do such type of a landing. So India considers this mission not only as a technology demonstration mission, but a mission which has got both aspects. One is a technology demonstration and other is to look for scientific endeavors and undertake some scientific experimentation.
Absolutely indeed, Dr. Lele. Do continue to stay on with us. Meanwhile, I'm told that we're also being joined by the former ISRO chairman, Dr. Madhavan Nair. He's joining us live from Trivandrum. Dr. Nair, this is a big moment for India, isn't it? We tried to soft land on the moon during the Chandrayaan-2 mission. We just very narrowly missed it. We were about 355 meters above the moon surface when we lost contact with the Chandrayaan-2 moon mission, but now we are attempting to land on the moon again. You know, tell us what are the challenges that await for India, and how is it that we would want to get things right this time round?
Well, I think the last mission, I will say that by and large it went correctly up to 2 kilometers above the surface of the moon. At the time, some anomaly in the control system has taken place, which has resulted in a tumbling motion of the spacecraft, which lost its control and which was not able to effectively reduce the velocity to the low value of about less than 2 meters per second. It impacted with about, I understand, about 30 to 40 meters per second. With that velocity, the entire spacecraft would have disintegrated. The soft landing maneuver is a very complex operation where, you know, unlike in air, once you break the Earth's orbit, the atmosphere comes to the rescue. And with the atmospheric drag, the velocity can be reduced considerably. And the ultimate final phase is using parachutes. One can have a soft touchdown. Whereas on the moon, there is no atmosphere.
Right.
So this entire operation has been done with the propulsion modules. And they have to compensate for the gravitational pull of the moon. And then very programmed manner, it has to take it down.
Right.
So at the 2 kilometers, they went into a fine control mode where virtually the spacecraft will be floating and it will be placed very slowly on the surface of the moon.
Absolutely.
So if either any sensor or the computer or its algorithm or the thrusters misbehave, this kind of thing can happen. The data available was very meager. So it was not possible to pinpoint, but at the same time, all possible modes of failure has been analyzed by ISRO, and they have taken action to strengthen all those elements which are found to be deficient or weak. For example, the landing gear is now stronger one. The propulsion module is redesigned with a fine mode of control, and the sensors are being provided with redundancy, and the algorithm for the mission management also has been modified. After this, a large number of simulations have been carried out, and the confidence obtained in those simulations, especially simulating the non-nominal conditions. In case some anomaly takes place, how the mission can be recovered. So all this has been done, and hopefully that will lead to a 100% success on 23rd of August.
Absolutely indeed. And also, Dr. Nair, you know, for the lay people who are watching this incredible journey that Chandrayaan-3 is presently on now, you know, a lot of people think that the spacecraft takes off from the Earth, it travels straight up and then it goes to the moon. You know, for a lay person who is watching us, tell us how this journey actually takes place. Because this rocket will first go into an elliptical orbit, and then it goes into ever larger elliptical orbits. And then it goes to a region where the gravitational pull of the Earth no longer covers it. And then the gravitational pull of the moon begins to attract this rocket system. Tell us in simple way as to how this actually works out.
Well, it is like this. Earth's gravitational field is the one which keeps the spacecraft around the Earth, and you know, it is just like tying a stone and rotating at the end of the rope and then rotating it. So as long as the velocity is high, the rope will remain straight. Similarly, when we have the gravitational pull and the centrifugal force which is coming out of the spacecraft balances, it stays there. So initially, what is done is using this heavy lift launcher, it is placed into a 200 kilometers by 36,000 kilometer orbit. That means closest to Earth it is around 200 kilometers and farthest point is around 36,000 kilometers. So that is a very respectable number. But from there to, of course, one can take a slingshot directly to the moon. But the uncertainties are very great because once you leave the gravitational field of Earth, the influence of the moon, the Mars, and even Sun becomes very predominant, and this influence coefficients has to be, basically, the once it gets out of the Earth's gravitational field, it will be subjected to the pull by the moon, the Mars, and other planets in the solar system, as well as Sun. So this has to be calibrated. To what extent the trajectory is deviated, and of course there's a tracking station in the Bangalore which will keep track of these movements. So the propulsion modules fire step by step, maybe about 5 or 6 steps, and raise it to about 120,000 kilometers, and from there give the escape velocity to travel towards moon. There, the velocity direction and the velocity magnitude are very critical. So then only it will reach closer to the moon. As it approaches the moon, the velocity is sufficiently high, and normally it will simply fly by. So at a precise moment, this propulsion module has to be operated again to reduce the velocity so that the moon can pull the entire spacecraft into its orbit. There again, initially it will be in elliptical orbit. Later, using the propulsion modules, step by step, it will be brought down to a 100-kilometer orbit. After it stabilizes at 100-kilometer orbit, the operation for descent maneuver will be initiated.
All right, very interesting. It's for the common people who are watching this, it's difficult to even wrap their heads around the kind of difficult calculations that will have to be done to put the rocket in the specific desired orbit so that it slowly reaches an area where it goes out of the Earth's gravitational field and then falls into the moon's gravitational field. But Dr. Lele, if I can bring you in on this, the technical aspects of this entire mission are tremendous. The place where we are trying to land in the South Pole of the moon, it is said that there are these craters on the South Pole of the moon where sunlight has not reached in millions of years. And that is what makes these craters in the South Pole of the moon so interesting and so important for us to land upon.
Definitely. You see, as far as the entire moon mineralogy, entire moon geography, everything has been mapped not only by Indian missions, but by the missions which have been sent by United States of America and few other countries also. So now there is a reasonable understanding about how the moon surface looks like, what are the heights of these mountains, what are the depths of the craters over there. So ISRO has undertaken all these sorts of available information. And remember, they have already an orbiter which is moving out over there. So orbiter is continuously sending the imageries. So based on all that sort of information, now ISRO has identified the exact landing zone on the moon, where there will not be any issues associated either with high mountains or the craters also. So a lot amount of precaution has been taken already by understanding where exactly the system should land. And more importantly, as the mission starts progressing more towards the moon, then another imagery will be picked up from the orbiter, some sort of a calibration will be done, and then only finally the decision will be taken on what landing zone the mission is to be landing.
Absolutely, indeed. And Dr. Nair, if I can give you the last word on this, it's not just in India where more than 1 billion people are watching. It is pretty much anyone who's interested in space and in space travel across the world is watching at this Chandrayaan-3 mission. And one of the reasons as to why India's space missions stand out for is the economy with which India is able to carry out these space missions successfully. Comparisons have been made about how India's space missions have often been cheaper than the budget of a Hollywood movie. So the question, sir, that I want to ask you is, how does ISRO do it?
Well, it goes to the credit of our founding father, like Dr. Vikram Sarabhai, who has really cultivated what is called the ISRO culture. This has been nurtured by people like Professor Dhawan, Dr. Kalam, Professor U.R. Rao, and so on. And today we have got a very vibrant organization who they're very enthusiastic engineers, technicians, and others are there to take on the technology challenges, irrespective of the remuneration what they get. The remuneration what you pay to the ISRO team is maybe about 1/10 of what they may get in a similar job in a developed country. That's one factor. Mm-hmm. The second thing is ISRO's careful planning and execution. So they have, ISRO has chalked out normally about a 10-year plan right from the beginning, and various elements of rockets, satellites, the application technology, etc., has been being developed continuously. And this development process makes use of what is already developed technology maximally. Right. Only the new elements are being introduced. See, for example, the GSLV Mark III, which has gone up, has got the propulsion modules derived from the PSLV.
Right. Absolutely, indeed. Thank you very much indeed to Dr. Nair and also to Dr. Lele for joining us on this broadcast and sharing your insights in this very important and crucial story. We'll be watching this very, very closely indeed, as India is, of course, embarking on a journey to script history to become only the 4th nation in the world to do a soft landing on the surface of the moon. WION is now available in your country. Download the app now and get all the news on the move.